Hello students, in today's class we will continue with chapter 6 sets. So first of all we will today discuss cardinal number. The number of elements in a finite set is called its cardinal number. It is denoted by n and in round bracket we write name of the set. So NA is for cardinal number. So let us take an example. If A is a set with elements 2, 4, 6, 8. Now if we count the number of elements, there are 4 elements in set A. So the cardinal number of set A is equal to 4. So it will be written as NA is equal to 4. If set A has one element that is 0, so we will consider this 0 as one element. So cardinal number will be 1. Alright. Then we have types of sets. First is finite set. A set is said to be finite if it has countable number of elements in it. Means we can count the number of elements in it. So let us take this example. Set A has elements A, B, C. So we know there are 3 elements. So where we can write the cardinal number, that set is a finite set. Alright. So if we want to write the cardinal number of set A, here we will write it as 3 because it has 3 elements. Same way, another example, if we have B, set of natural numbers up to 10. So it means cardinal number of B will be equal to 10. So it is a finite set. Alright. Second is infinite set. A set that contains uncountable number of elements is called an infinite set. We cannot define cardinal number of an infinite set. Means where we have unlimited number of elements. So that is an infinite set. So let us take this an example. Set A is a set of all even numbers. Now we have uncountable even numbers. So it is an infinite set. Alright. So another example, B is a set with elements 1, 2, 3, 4 and so on. When there is no limit, it means it is an infinite set. So these A and B, two sets are infinite sets. Alright. Third type is empty set. A set containing no element is called an empty set. Means when there is no element in the set. It is known as null set or void set. Alright, it is denoted by phi. This symbol is for phi. Alright, or we put here phi or empty braces, means without any element. So this symbol or this phi, any one of it can be used for empty set. Let us take examples of empty set. Set A has triangles with 4 sides. So we know there is no such triangle with 4 sides. So this is an empty set. Alright. Then another example, set B, day of the week starting with letter A. Now we know we do not have any day starting with letter A. So this is also an empty set. Alright. Then if we write phi, the sign of empty set in curly bracket, now it will not be an empty set. Alright. So either we put braces, empty braces or phi separately, then it will be an empty set. Both together will not be an empty set. Now there is one element in the set. This element is phi. Alright. So or if we write 0 in curly bracket, then also there is one element in the set. So these two are not empty sets. Next type is equal sets. Two sets are said to be equal if they have same elements in any order. Means if two sets have the same elements irrespective of the order of the elements. For example, here we can take, if we write set A with elements 1, 2, 3 and B is a set with elements 2, 1, 3. Now set A and B both are having same elements, same three elements. So we will say that set A is equal to set B. Alright. So we write A is equal to B for equal sets and A not equal to. This is the sign for not equal to. A is not equal to B for unequal sets. Alright. Now let us take another example. If A is a set with elements 1, 3, 5, 7, 9 and B is a set with odd numbers less than 10. Now we know odd numbers less than 10, if we write in roster form, it will be 1, 3, 5, 7 and 9 only. Alright, so this is the roster form of set B. Now we can see set A has 1, 3, 5, 7, 9, set B has 1, 3, 5, 7, 9. It means same 5 elements in both the sets. So we will say that set A is equal to set B. Alright, but if we take another example, set A has elements 1, 2, 3, 4, 5 and set B has elements 2, 4, 6, 8, 10. Now here A and B have different elements. Alright, so we will say that A is not equal to B. Next we have equivalent sets. Two sets are said to be equivalent if they have the same number of elements. Means they should have only the count should be same. That is cardinal number of both. Next we have equivalent sets. Two sets are said to be equivalent if they have same number of elements. Means if the count of elements in both the sets is same, we will say that sets are equivalent. That is cardinal number of both the sets are equal. If A and B are two equivalent sets, we write A equivalent B. This is the sign for equivalence. This is the sign of equivalence here. Now let us take an example. Set A has elements 2, 4, 6, 8. So what will be the cardinal number of set A? That is 4. Now B is another set with elements A, B, C, D. Now the cardinal number of set B is equal to 4. Now we can see both the sets have different elements, but the count of elements, that is cardinal number, is same in both. So we will say that set A is equivalent to set B. Alright. Now let us take another example. X is equal to MATH and Y is equal to HAMT. Now here in both the sets X and Y, we can see that they both have same 4 elements. It means the cardinal number for X is 4 as well as cardinal number of Y is also 4. So we can say that X is equivalent to Y. Alright. Now here we can see X is equal to Y also. Why equal? Because same 4 elements in both. Alright. So you can see here that every equal set is an equivalent set. Alright, every equal set is an equivalent set, but here we can see every equivalent set is not an equal set. Here we can see that A is not equal to B. Alright, so the condition is every equal set is an equivalent set, but every equivalent set may not be or may be equal. Okay, next is singleton set. A set having one element is called a singleton set when there is only one element in the set. So this is an example, set of even prime numbers. Now we know there is only one even prime number, that is 2. So we will write A is a singleton set. Alright. Now here in this another example, vowels in the word math. Here also we can see there is only one vowel in this word A. So this B is having only one element A. Alright. So this is also a singleton set. Next type is overlapping sets. Two sets are said to be overlapping sets or joint sets if they have at least one element in common. It means if two sets have some elements common, at least one should be there. Common means both the sets having the same element. Alright. So two sets are, if they have one element or more in common, we will say that they are overlapping sets or joint sets. Now in this example, A is a set with elements 1, 2, 3, 4 up to 10, means first 10 natural numbers, and B is a set with only even prime number. Now we know if we write B in roster form, we have only one element 2 in this set. Now if we compare these two sets, 2 is present in B as well as it is present in A. It means one element is common. So we will say that A and B are overlapping sets. Alright, let us take another example. Here A is a set in which we have letters in the word apple. Now if we have to write it in roster form, we will write A, P, L and E. Alright, and B is a set in which we have letters in the word pear. So here we will have elements P, E, A and R. So now this set A and this set B have elements common in them. A, P, E. Three elements are common here. So we will say that A and B are overlapping sets. Alright, I hope you have understood. When there is something common, common means which is present in both, we will say that sets are overlapping. Next we have disjoint sets. Two sets are said to be disjoint or non-overlapping sets if they have no element in common. It means two sets, if they are totally different, there is nothing common in them, we will say that these are disjoint sets. So let us take an example. Set A has elements 1, 3, 5, 7. Set B has elements 2, 4, 6, 8. So we will say that A and B are disjoint as they have no element in common. Alright, so they have no element in common. Alright, let us take another example. X, all vowels in English alphabet, and Y, all consonants in English alphabet. Here also X and Y are disjoint sets. These are disjoint sets because there is nothing common in between vowels and consonants. Now let us start with exercise 6.1. First 4 questions we had already done in the previous class. Now we are going to start with question number 5. Question number 5 is we have to find which are null sets. Null set means when there is no element in the set. Alright. The set of all prime numbers lying between 15 and 19. So is there any prime number which is there in between 15 and 19? Yes, 17 is a prime number which is lying between 15 and 19. So if we have to write the roster form of this set, it will be 17. Alright, so it means it has one element, so it is not a null set because there is a one element in the set. Next, fifth part is D is equal to X such that X is a vowel in the word cry. Is there any vowel in this word cry? No. So here I can write that D is an empty set or null set. It can be written by empty braces or phi sign. Both works for it. Alright. So D is a null set. This is a null set. Question number 6 is we have to find finite or infinite set. Second part is X such that X belongs to N stands for natural numbers, and X is an odd number. It means this is a set of odd natural numbers. Now we have unlimited odd natural number. So it means this is an infinite set. Alright. So we will write it as infinite set. Then fourth part is the set of prime numbers less than 90. Now the limit is 90. It means when there is limit, this is a finite set. Alright. Question number 7 is we have to find equal sets. Now A is a set with elements prime numbers less than 6. Now if we write it in roster form, we have A is equal to 2, 3 and 5, and B is a set with elements 2 and 3. Alright, so here we have 3 elements, here we have 2 elements. So we will write here as they have different number of elements, so A is not equal to B. The fourth part is set of letters of the word follow and Y letters of the word wolf. So if we write them in roster form, you can see here we will write it as FOLW, and here in set B we have WOLF. So here we have same 4 elements in both the sets. So it means here we have A equal to B. Next we have question number 8, write cardinal number. First is A is equal to X such that X belongs to N and X is less than equal to 6. It means if we have to write it in roster form, we will get here first 6 natural numbers. So we will write it as 1, 2, 3, 4, 5, 6. So when we will write the cardinal number of set A, that is equal to 6. Alright. Then next third part is set of prime numbers which lie between 6 and 16. So let us give it names B, and when we write it in roster form, here we will have 7, 11 and 13. So there are 3 elements, 3 prime numbers. So cardinal number of set B is equal to 3. Alright. Then question number 9 is disjoint and overlapping sets. Now we know disjoint sets means when there is nothing common, there is no common element in 2 sets, and overlapping sets means which have at least one element in common. Alright. So here third part is A X such that X is equal to 7n. 7n means multiples of 7. Here these multiples will be natural numbers, and n is less than 8 means up to 7 we have to multiply. Less than 8 means up to 7. So it means when we write it in roster form, it will be 7 into 1, 7 into 2, 7 into 3, 7 into 4, 7 into 5, 7 into 6 and 7 into 7. This is the roster form. Less than 8 means up to 7 we are multiplying. Same way in set B, here we have 8 and means multiples of 8. Less than 8 means up to 7 only. So here we will write table of 8. 8 into 1, 8 into 2, 8 into 3, 8 into 4, 8 into 5, 8 into 6, 8 into 7. Now in these two sets we can see there is no element common in them. So these two are disjoint sets. Next, 10th question is equivalent sets. Equivalent set means two sets if they have the same cardinal number. Alright. Now this first part is set of letters of the word talk. Here we can see if we have to write it in roster form, we will write it as TALK, and Y is a set of letters in the word flow. Here it means we will write it as FLOW. Now in set X, the cardinal number is 4. In set Y, the cardinal number is 4. So both the sets have the same cardinal number. So X is equivalent to Y. Alright. Third part is A is a set of natural numbers which divide 12 exactly. So here, if we have to write this set A in roster form, we will get 2, 3, 4 and 6. Alright. And in set B, natural numbers which divide 30 exactly. So we will write here 2, 3, 5, 6, 10 and 15. Now the cardinal number of A we can see here it is 4 and cardinal number of B is here 6. Now as cardinal number of A is not equal to cardinal number of B, so A is not equivalent to B. A is not equivalent to B. So with this we have completed our exercise 6.1. Few parts from each question I have done. You people will complete this exercise in your registers.